Hello and welcome to the solutions video for the Unit 7 unit exam. So this is on trigonometry. How would you determine the indicated angle measure if possible? So we're either looking at sine law, SOHCAHTOA, or the cosine law, or not enough information. The information we're given are three sides. Side, side, side. That is a cosine law situation. Number 2, the three sides of a triangle have measures of 4 centimeters, 6 centimeters, and 7 centimeters. The measure of the smallest angle in this triangle to the nearest degree is. So again, we're given side, side, side. That makes it a cosine law situation. The smallest angle, we have two approaches. We could solve for all three angles and see which is the smallest, or you can recall that the smallest angle will be opposite the smallest side. So we want the angle opposite 4 centimeters. Okay, sorry, let's get the whiteboard up and running here. So, not to scale, but we have a triangle. We've got 4, 6, and 7 centimeters. That's the angle we're looking for. We have c squared equals a squared plus b squared minus 2ab cosine c. Angle c would be the one that we're looking for, so side c has to be the 4 centimeter side. We can do our manipulations to get that the cosine of c is a squared plus b squared minus c squared all over 2ab. So then, actually we'll go angle c itself is the inverse cos. Now the 6 and 7 here are interchangeable. So then angle C, running through our calculator, works out to 35 degrees. A triangle has angle A is 30, angle B is 80, and side A is 120. What is the measure of side length C to the nearest tenth of a centimeter? So we're only given one side. Cannot use the cosine law. This has to be a sine law problem. If we want side C, we need angle C, which was not provided. But we know that the three angles add up to 180. So angle C has to be a 70-degree angle. So then, A over sine A equals C over sine C. So side C is A over sine A times sine C. And that is 12.0 centimeters all over the sine of 30 degrees. Now sine C we said was 70 degrees because they add up to 180. And when we work that one out, it rounds to our 22.6. Once we knew that side C was 110 degrees, we should have known it was greater than side A. So we could have narrowed it down to A and D here. We just had to figure out which of those it was. A would be the one if you accidentally used the 80 degrees instead of 110. Right. So the coordinates of a point Q on the terminal arm of an angle in standard position are shown below. The exact value of sine theta is. So here we have x, which is cosine, is negative 8. The y would be sine, or at least cosine times the hypotenuse, and y is the sine times the hypotenuse, that's 6. So sine times the hypotenuse equals 6, so the sine theta is 6 over the value of the hypotenuse. It has to be positive, so we're actually going to end up with that 3 over 5. Our hypotenuse here would be 10. 6 squared plus 8 squared. But as soon as we know we had 6 in the denominator, right, and you're going to have a whole number, that means it's going to reduce by a factor of 2. Sign is positive in quadrant 2, and it has to have a factor of 3 in it. We might be able to cancel the 2 or the 3, but it is the 3 over 5. The measure of angle theta to the nearest degree would then be the inverse sine of 3 over 5, or 0.6. So to the nearest degree, our calculator is giving us 37. But remember, our calculator only gives us quadrant 1, and we're in quadrant 2. We have to take 180 minus 37 to get to 143. So which diagram represents an angle of 210 in standard position? They're all starting in the right place and going in the right direction. You have to go through the full 180 and then 30 more. So that's diagram A. And just to clarify, it's not diagram C because that 30 is being measured from the wrong point. It's not diagram D because that angle would have to be 60 and not 50. So if cosine is negative and tan is positive, well, if cosine is negative, we're in quadrant 2 or 3. If tan is positive, we're in 1 or 3. Therefore, we must be in quadrant 3. That's option C. So now here, distance from Q to P. This we're going to have to do in stages, because all we know about triangle QPS are the angles. We were given 2, so we can easily come up with the third. So what we need to do is find one of these lengths. We can do that with angle QRS. We can use length QR to find this shared side. So that then is a sine law. We know 2 of these 3 angles, the 31 and the 69, which means these add up to 100 degrees, so this angle is 80 in that bottom. So the angle between QSR, the unknown angle from the right-hand triangle, has to be 80 degrees. That's the piece we need. So we know that 5.8 kilometers over sine 80 is equal to the unknown over the sine of 69 degrees. Actually hit the arrow I'm looking for instead of clear, I can do this much more quickly than I'm doing it now. Alright, so I'm getting x is a 5.498297975. Again, we use the unrounded values in our calculators. And I guess it was bad form to use an x there because there is an x given in the question. So now, this angle is the 5.4. So our 5.498297975 yada 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 over the sine of the side opposite it, which is 58, is the current unknown over the sine of 47 degrees. So we take our last answer and multiply by the sine of 47 divided by the sine of 58, and then we get a 4.7417, or to the nearest tenth, 4.7. So now, numeric response number 4. If the sine of theta is at negative 5 over 13 and cos is also negative, then the tangent of theta is 5 over m. The value of m is. So sine and cosine are both negative. We're in quadrant 3 where tan is positive. So m is going to have a positive value. This tells us that our triangle so here's our triangle. We're in quadrant 3. That actually should have been drawn the other way because we're in quadrant 3. So here is our triangle. So our opposite over hypotenuse, we don't know exactly what that is, so we could put in r's for a scaling factor, but these are the proportions. So this side is going to be the square root of 13r squared minus 5r squared, which works out to 12r. So the tan of theta, which is opposite over adjacent, these are both negative in quadrant 3, is a negative 5r over a negative 12r. So tan theta is 5 over 12, and m is 12. The reference angle for theta equals 214 in standard position. The reference angle is the difference between the x-axis and the angle, or the closest side of the x-axis and the angle. The closest side here would be the negative x-axis because we're in quadrant 3. So 214 minus 180 gives us 34. You will never have a negative reference angle or a reference angle that exceeds 90. So only B and C were viable options.
You like someone else, please?
Now we have the point P of x and negative y. What other point has the same reference angle as point P? So which one will have the same angle closest, or to the side closest to our x-axis? One way to evaluate that is to look at the tan. So the tangent of this function, the opposite over adjacent, here would be a negative y over x. Point G would also have a tangent that works out to negative y over x. So that will have the same reference angle. Finally, an angle of 59 degrees is reflected over the y-axis. The resulting angle in standard position to the nearest whole number is. So if we have an angle, that is terrible. I'm going to go to the actual line tools. So we have a line coming out this way. If it's reflected over the y-axis, now it's going to come out this way. It's like we put a mirror in the y-axis. So if that's 59 degrees, this will have that same 59 degree reference angle. So the actual angle here is 180 minus 59, which is 121. So this concludes the solutions video for our Unit 7 unit exam.